Okay, on to problem number 3. So this is SSA form and optimization. So for the first problem here, it says rewrite the following code and put it into SSA form. So SSA form is we only assign each variable once, and then we create a new copy if we're going to assign it again. So we'll say x1 equals 5, x2 equals x1 plus 1, y1 equals x2, that's our most recent copy of x, plus 3. So basically every time we have something on the left-hand side, we're going to increase the number that's next to it, and we're going to use the most recent number for each variable on the right-hand side. So then x3 equals x2 plus 3, and then z1 equals x3 plus 3. Okay. So that's it. We're really just, adding a number. We only assign y and z once, so they are just y1 and z1. X gets assigned 3 times, so it has 3 copies. Part B, using the SSA form you generated above, which operations could be eliminated by value numbering? So value numbering is identifying things that are exactly the same, and it's pretty easy in this one since we see that these two operations, x2 plus 3, that's the same thing. So we could get rid of y1 equals x2 plus 3, or x3 equals x2 plus 3 could be eliminated. One or the other of those, it could just be the same thing. Y1 and x3 are the same values. Part C, perform constant propagation on the code above. You should assume that y and z are live out of the basic blocks, but x is not live out. List the resulting code here. So part of this is to understand that we do want to keep the values in y and z. So we're assuming that those are live out. We need them after this is finished. So we cannot get rid of the y and z values. But however, x can go away. So we could list some intermediate values here. We know that x1 is 5, so we could get rid of the x1 equals 5 part and just say x2 equals 5 plus 1. Y1 equals x2 plus 3. I'm very pedantic here. x3 equals x2 plus 3. And z1 equals x3 plus 3. So that's what we'd have after that. We can see that x2 becomes 6. So then in our next phase, we could do y1 equals 6 plus 3. X3, we said we could eliminate x3 in the previous step, so we could do that at this point if we want to, or we could just assume that we had already gotten rid of it here, and we substituted because y is the same value. We could make that y1 plus 3 for z. So let's assume that we've done that. We've got y1 equals 6 plus 3 here, and we've got z1 equals y1 plus 3. And then at that point, we've got y1 equals 9, and z1 equals, well, y1 plus 3, so 9 plus 1, 12. And we do have to keep these two values. We don't want to eliminate these entirely because we are saying that those are live out, so we need those values somewhere else. Next question is just definitions to define a basic block. Basic block is a stream of instructions or a set of instructions with a single entry point and a single exit point. So that's it. And then define a phi node, and we might say something like a phi node joins divergent control flow values in SSA form. So if you remember, a phi node is what we use to deal with the fact that we only assign something once in SSA, and if we have an if statement where we have a true branch and a false branch, we have to deal with the fact that the control flow splits, and therefore values might have two different values. So we use a phi node to effectively join them together when we get back. And that's it for question 3.